Okay, but doesn't matter, you know that tau and t are the same thing. Okay, convolve these two functions. You can choose to flip either one of them, it doesn't matter. Let's, as the textbook does, flip f of tau. Okay? The textbook flips the first one. Okay, if you flip this one, it flips over something like this. It becomes 1. This is minus 1. So f of tau looks something like that. And then you're supposed to make the second function move with respect to time. So, if I were to ask you to plot f of t minus tau, how would it look like? Okay, so it will look like something like this. Right? F of t minus tau must have moved to the right, but what is this point over here? What is this value over here? That is the value when tau equals what? Yes? T minus 1, you're looking at the textbook.
No.
No? So, this is the value of tau such that when you put in this value over here, okay, put in that value over here, you get minus 1. So you want that tau, when it's equal to t plus 1, okay, if tau is equal to t plus 1, you plug it in here, you get f of minus 1. You get this value over here. So tau should be t plus 1 when that thing goes to 0. Okay? Now you multiply this with that. Okay? So for a while, if you compute the output now, for a while nothing happens. Nothing happens until this function moves far enough to the right that it hits this function and create an overlap integral. So how much must this function move? What must t be? What must t be in order for this function to overlap with that function?
5.
T plus 1 must be equal to 5. So what must t be? 4. Okay? So t plus 1 must be equal to 5 before it hits it. So t must start with 4. Okay? When it hits the other function, it picks up an integral. The integral initially was 0. Does it jump abruptly to some value or does it increase gradually? Increases gradually. And does it increase linearly or quadratically? Linearly. Okay, very good. So it just increased linearly. Okay? Until it picks up when t equals to 5. Okay, when t equals to 5, the overlap is complete. The overlap is complete. And what is the area under the overlap area? What is the total area for the overlap integral? Is equal to? This is 2, right? This is 1. So it's 2 times 1, right? So it's 2. Right?
Oh,
No? Not 2?
no, I remember.
Okay, it's 2. It picks up to the value of 2, and then it just remains constant thereafter. Okay? It remains constant thereafter. This is the answer. I have 2 more examples to do, but I don't think I have 3 more examples for section 9.1.3. Quite long, right? So let me do just one more example. I think I have time for one more example, and then we can leave the other 2 examples later on. And actually, I'm very anxious to tell you the physical meaning of convolution. And you haven't heard about that. Okay? And that meaning of convolution comes about only in section 9.2. You have been doing all this exercise but not knowing the meaning of convolution. Okay? So maybe I can start telling you the secret of convolution in the next lecture. Okay, but I do not want to let the cat out of the bag now. Okay? So I will not tell you the secret right now, but next lecture I will tell you the secret. But let me finish the last example. Okay, the last example is, I have 5 minutes to do it, so I have f of tau, looks something like this, 1 tau. Okay, I have h of tau, not a simple function anymore, but a triangle function. 2 tau, and then this is equal to 4. And then you convolve these two functions. One simple way is to flip this around. Flip this around, f of minus tau will look something like this. And then as you move this to the right, f of t minus tau will look something like that. This is minus 1. So this is something like t minus 1. Okay? This is tau. So f of t minus tau would be something like that, and we multiply these two functions together and then integrate. So y of t, when would you have non-zero value? The moment that t is larger than 0, you start to have an overlap. Okay, so it goes to 0 here, is 0, but I start to pick up something. Okay, but it's this thing multiplied by this thing and integrate. Before that, we just multiply two constant functions and integrate. We get a linear functions in time. Now if you have a constant function times a linear function in time and integrate, what do you get? A quadratic function. When you integrate a linear function, you get a quadratic function. So you have something that picks up quadratically, okay, quadratically, until when this thing here hits something like this over here. Okay? And that is when t equals 2. When t equals 2, it reaches its maximum. So when t equals 2, it reaches its maximum, as you can see from this picture. And after t larger than 2, the overlap integral starts to diminish. Okay? But it's still integrating a linear function. Okay? So it must be diminishing in the manner, diminishing to 0 somewhere. When does it diminish to 0? When t equals to what? T equals to 3, right? When t equals to 3, there's no more overlap. But it must diminish quadratically. Okay, it must diminish quadratically. It has two choices. One is to diminish like this, the other one is to diminish like this, quadratically. So which one do you think should be the correct answer? What? There are two ways to fit these 2 points with a quadratic function. One is like this, and then the other one is like this. Both of them are quadratic. The second one, okay, the second one. Okay, second one. Okay, so both of them are not straight lines, and both of them are quadratic. And as to why it should be that way, you have to work out the detail. I don't have a quick answer for it. Okay, I think it can diminish this way or that way, but it turns out that the answer is that it diminishes that way. You can fit 2 points with.
So the first one is upward variable, the second one is inverse.
Yeah, because if you have a quadratic function a plus bt plus ct squared. There are 3 constants,
Yeah.
and you have only 2 points. You're only fitting this through 2 points. You only have 2 equations, so that you have more than one way to fit this.
So that means the coefficient C is negative.
Well, if it's convex or concave, okay, then it has something to do with the second derivative. Okay, and I don't have a quick answer as to why it should be convex instead of concave. Okay.
Oh, okay.
For the middle one?